flaw that you need to consider when managing or taking care of a building. So I didn't know that we have that number of floor types, and it actually broadened my knowledge on other consideration that we can actually give to our clients when making proposals. Thank you.
Okay, that was a great one. Can Adiola Antonio B give us a takeaway from the last class? Adiola Antonio B, are you there? Okay, the facilitator is now around, and I would like to hand over the balance of time to him. Mr. Abel, over to you, sir.
Yeah, good afternoon, everyone. Good evening, everyone.
Good evening, sir.
Good evening.
Good evening.
Good evening.
Sorry for coming a bit late. As a kind of network issue here. I hope you can all see my screen.
No.
Really?
Yes.
Can you see my screen?
Not yet, sir.
Okay. Can you all see it now? Akindele Olusegun. May I start with you if you are part of?
We cannot hear from here. I don't know if it is only me.
I can hear you clearly. Can you hear
Your
me?
voice is faint. We can't hear you.
Okay, let me try something. Can you hear me now?
Yeah, it seems better now.
Yes.
Okay. Yeah,
Yes,
let me use the
we can hear you.
direct. Let me use the direct instead of using the earpiece. Okay, good to meet you. My name is Abel, your facilitator for today's class. I would like to meet every one of you so that I'll know who I'm interacting with. If you can hear me, start by introducing yourself. Hello.
Good evening. Good evening, sir.
My name is Abel Iyoriowe. I'm your
My name is Theophilus Bayode.
Okay, good to meet you, Theophilus.
You're welcome, sir.
If you can hear me, just go ahead and introduce yourself.
Okay, good evening, everybody. My name is Unduka Alexis.
My name is Kiki.
Thanks for meeting you.
Good evening. My name is Patrick Agabu.
Good evening. My name is Amalika Ode.
All right.
My name is Ekwase Imo.
Good evening, sir. Good evening, sir. My name is Bamidele Uroleke.
Okay, good to meet you.
My name is Michael Benrodada.
Okay, good to meet you, Michael.
Good evening. My name is Iweno Fichuchu from Abuja.
All right, good to meet you.
Good evening, everyone. My name is Adiola.
Anthony Obi.
Yes, Adiola Anthony Obi.
Okay, good to meet you. All right.
My name is Lilian Asho.
Okay, good to meet you all. As time goes on, we'll be introducing ourselves. So let's proceed with the class right away so that I won't take much of your time because it took me time to be able to connect to the network. Once again, good evening and welcome to the class. You all know the class rule. Let me quickly screen through so that you know So we have done introduction. So these are the rules governing this class between now and the end of the class. And I know you are all law-abiding students. We stick to it. Thank you once again. So the objective of this course is that at the end of this course, the participant or the student will be able to understand the basis of electrical energy and power, be able to carry out load analysis, energy analysis and its importance. You want to know power factor as a function of generator size determinant. So how you can use power factor to determine the size of your generator. You know all the sources of power and its advantages, why you choose to exploit the one you want to explore. So you know various generator components and their functions. The importance of equipment maintenance, it cannot be overemphasized. You know transformer and their functions and the importance of earthing in your installation. So these are the course outline. We have module 1, introduction, know the definitions of power, power generation as a network of interrelated equipment, sources of power, type of power, where you have the direct and alternative power source. Module 2 is component of power. What makes us power? We have the loads, the conductor, the electrical installations, and protective devices, and their usefulness. We have 2 types of installation. We have the radial and the ring. You know why you should prefer one to another at the end of the class. So we have the distribution board and circuit breaker. Our number 3 module here is generator maintenance and diesel management. So not everyone would like to pay attention to generator maintenance and diesel management. So at the end of this class, you should be able to know why maintenance of generator and adequate record of diesel management is necessary in your facility management. In module 4, which we are going to be looking at, is the earthing and grounding system. Why is earthing so important at the end of the installation? Why do I need to bother myself regarding earthing system in a building? So assessment of students will follow after the course. Are we together? So we start by introducing to what is called power. Many people often confuse power to be energy or energy to be power. So in this course, we are going to know the difference between power and energy. So power is the interconnection of electrical component for supply and transfer of electrical power. So you know the operation of power system, that's the generation, how power is generated and be fed into your building. So the process of transforming energy into electrical form, and this subsystem produces electricity. So this is the interconnection of electrical equipment that makes up your generating station, the transmission and the distribution. In Nigeria, we have generating stations. They are not responsible for the transmission of this power to where they are needed. We have the transmission company that's responsible for that. Please, if you are in a noisy place, mute your device so that it will not be interfering with what we are doing here. I can hear some horn background and so that you won't disturb others that are paying attention. I know you have heard me. So electrical and power system is made up of generating station, transmitting station, transmission lines, distribution line, as well as the consumers. Like in the normal commerce or economics, it said a producer have not produced anything until the consumers are satisfied. The same way, you have not produced electricity until it gets to the people or the customer that require this electricity for to drive their appliances or equipment. So as you can see, this is the generating station. It could be some level of power generated from here, could be under or over. So it needs to be modified so that it will not be a nuisance to the end users. So this is a transformer that modifies this generated power into what is required to be transmitted. This is a transformer. It only modifies what has been generated from here. So this is the transmission line. When you travel along the Nigeria road, you will see this transmission line. So they are used to carry power from where they are generated to where it is needed. So this is another substation where this power is further modified to suit the demand of the users. Again, this is another transformer. Maybe it's stepping it down from 132, as the case may be, or 330 kV to 11 kV, from 11 to 450, and so on. So this is where it is needed. These are the consumer, the commercial consumers, and the domestic consumers. So we do not require the same amount of energy or power to drive our load. As we move ahead, you will see why we need various voltage levels in our homes. So basics of electric power. There are things that come together to form electricity. They are voltage and current, as well as resistance. So here, the product of current and voltage gives you power. So we have the direct current and the alternating current. What do you mean by direct current? Current which give out steady electricity without interruption, without distortion. So they give steady electricity, constant electricity. So they provide constant current or voltage. They are generated through battery, rectifier, and most computers and digital equipment use this DC power. On the other hand, we have alternating current. They are transmitted over a long distance, like we saw here. This is alternating current that is transmitted over this long distance. You can see the distance is traveling to where they are needed. So that is alternating current, a current that alternates instantaneously. It is not steady like the direct current. So they are generated through alternator. And equipment that use this alternating current are your refrigerator, air condition, and pumps, lifts, all those high power demand, like the three-phase motor, your lift, your elevator, your escalator, your broiler, they all make use of alternating current. DC current, the first one we've looked at, will not be able to operate these three-phase machines. So that is why alternating current, AC, is used to drive this our heavy-duty machine. So, component of power system. There are various sources of power. Some are part of the equipment, some are external, like the laptop or the device that you are using, either phone or whatever. The power is inbuilt. Whether you like it or not, you have power in that your device. That's why you are able to put it on. Like your battery is a source of power. So it's part of your equipment. There are some which are external, like your generator in your facility, like the EKEDC or IKDC or Bini distribution, or wherever you are participating from. So these are external sources of power. They are not domiciled in your home. They are generated elsewhere and transferred into your home for use. While the one on our laptop here and the one on your phone, they are inbuilt. So we have what we call load. Some people don't know what is, when we are saying load, the load that the gen or the power is subjected to is high. Load is everything in your home that requires electricity for its operation. That is what we call load. Example of loads are your fans, your refrigerator, your home theater, your television, your electric iron. These are all loads put together for your electricity to operate. Power delivers energy to load. Without power, whatever thing you have put into your home is useless. So you need power to drive these your appliances. So load ranges from industrial equipment to household appliances. Like I told you, your lift, your elevator, your escalator in your building, they are all industrial appliances. Like your bulb, your LED light, and so on, television, they all form part of the load on your computer in your building. So you need to pay adequate attention to the type of supply that you are demanding when you are calling for electricity. So load are expected to run at a certain frequency and phases. Like most people, they don't know the difference between the three-phase and the single-phase. We have three-phase equipment. We have single-phase equipment. Like your blender at home, they are single-phase equipment. The lift that you are operating as three-phase equipment. Your chiller, they are three-phase equipment. When you are calling for power, you need to determine them by the type of load you have in your building or your facility. So you have to take note, we have the three-phase equipment and the single-phase equipment. So the three-phase equipment runs on line to line, that's 400 or 415, while the single-phase equipment run on 220 to 240 volts. So the three-phase run on 400, 415, while the single-phase run on 240 or 220 volts. So they cannot do the same thing. So any appliances must have a specific wattage. What does that mean? It means that every equipment, every appliance is rated at a certain power range. That's why in your home, you have your electric iron to be 1,500 watts. Your pumping machine may be 2 horsepower. These are ranges by which these equipment are named. With that, you're able to determine how you operate your generator or your electricity supply, so that you will not overload your generator. You say, oh, generator is 10 kV, it's 20 kV. Hello, as I've said, please, if you're in a noisy place, just mute your phone or your device and listen to what we are saying in this class. Thank you. As I was saying, equipment are rated in various wattage. Like your machine, you have 2 horsepower, 3 horsepower, 5.5 horsepower, and 7.5 horsepower. So this enables you to adequately manage your generating machine, your generator. So that you will not overload it. You will, maybe the bill they are bringing to you say it's too high. Maybe you are subjecting your electric system, your power system to heavy load. The more you subject your supply to heavy load, the more bill you are expected to pay. So if you know how your equipment are rated, you know how to put them on at every point in time. Like some people will plug their electric iron and leave it on. You feel it's free. It's not free. It's either you are overloading your generator or you are incurring unnecessary costs. So when you know the wattage of your equipment, you'll be able to moderate your cost, your bill at the end of the month, or your diesel consumption or petrol consumption. So everything is tied to cost. Whatever wastage you are practicing at home, everything, someone is paying for it. You may feel it's free. My daddy owns the building. It's our company, this, that. So you are actually incurring unnecessary costs. When you pay attention, you know when to put on some appliances and when not to put them on. When you are considering your load, power quality must be considered. The quality of your power must be like the low voltage. Of recent, I had an experience in my home. They supplied me low voltage. Someone went and plugged my cooker, and that affected it because it spoiled it. So because there was a supply, but the quality was not okay. It wasn't clean. It was fluctuating and low voltage. At the end of the day, the equipment got spoiled. So before you put your load on power supply, you have to ensure that the quality of the power that is coming is clean, is okay, is at a certain value and at a certain frequency. So equipment power is supposed to operate at a certain frequency, like 50 Hz or plus or minus 49 or 51 Hz, at the case 52 as the case may be. That is standard frequency. Between 50 and 52 and 50 down to 58, 48, I mean. Anything outside that is out of range, your equipment might damage. You may feel, oh, what happened? You use this lamp. Maybe the frequency was not okay, or there was high voltage or low voltage that damaged your equipment. So you need to pay attention to these parameters. I know you may not be patient enough to go and check at what level. You should have something that will tell you, maybe a bulb that will be blinking, or that will not, face failure, that will not allow the passage of those unclean or undesirable supply to get into your apartment or your building. So you put measure in place so that any phase that is not okay, any supply that is not okay will not be allowed into the building. It doesn't cost much. So when you know this, you're able to manage your power effectively and your equipment will last for you. We have conductors. What are conductors? Conductors are anything that allow the passage from one point to another. They are also known as cable or wires that we are used to, but electrically it is called conductor. So what do? They carry power from the generators to the load where it is needed. Some people are used to almond cable, some are used to flex cable, some are used to PVC cable. So their function is to carry supply from where it is generated to where it is needed. But you have to get the size right as well, so that you don't just buy, at the end of the day, the cable gets spoiled along the line. You have to get the right size of the cable that you need that will power your desired load. So we have protective device. So what are the function of protective device? They prevent damage during failure or injury, like your circuit breaker, your fuse. Instead of fuse to be electrocuted that will result to death, the breaker will open automatically. So they serve as protection to the personnel as well as the installed equipment in a building. So a typical protective device is the fuse. The fuse element merge when current exceeds a certain threshold. So it means whether you are there or not, the fuse will just blow off and it will protect your equipment, maybe your television or your projector or whatever that is meant to protect. But fuse has a very disadvantage effect. So most people abuse fuse by putting wire and thinking that they have done well. They put oversized fuse and it doesn't serve as a protective device anymore. It only serves as a link. So when there is a problem, the fuse is meant to open or melt. Because the wire is overrated, it doesn't open anymore. What happens? It damages the equipment that is meant to protect. So it damages the equipment that is meant to protect. So we have the capacitor and also the reactors. So what do? They are used to reduce current demand on power system. Okay. So they are used to reduce current demand on power system, used to limit fault current as well. So we also have power electronics. What do? They convert AC power to DC power. So they are all used for protection. AC power to DC power. They are semiconductors devices. So they switches quantity of power ranging from few hundreds watts to several hundreds of wattage. So we have type of power system. We have the residential power system, which I have explained to you, and the commercial power system. So low voltage distribution line, they are for residential. So these are the ones you see on your street, like 11 kV to 450 kV. So we have also the commercial one that make use of large scale power, ranging from 130, 132, 330, 33 kV, and so on. So depends on what you are looking for, you go for such power. We have bulb and office electrical installation. During my introduction, I told you we have what we call the radial and the ring installation. So here is a distribution board. I told you about fuse. Fuse has been phased out because of its disadvantage, what it has caused on installation work. So we now make use of distribution board that house circuit breaker rated in various capacity. So from the distribution board, you can see a 30-amp fuse breaker where the socket outlet are attached to. You can see 25 amps where electric heater or cooker is attached to. So with the distribution board, you have no problem tracing where a fault is coming from. You can just go there and see that the breaker is tripped. What you need to do is to identify what caused that trip and make sure that problem is resolved before you close back the breaker. It makes work easy for anybody. We have the ring. We have the ring. We have the ring. Sorry. Yeah. We have the rings from. We have the ring circuit from a complete ring running from the CIS, that is consumer control unit, to all the socket and back to the consumer control unit. That's the ring type of installation. They run from this consumer control unit to all the socket and back to the consumer home. What that means, they start looping it. The disadvantage of this is that you are overloading the source of that supply. So another person may come and a side extension, just plug extension, they are extended like that. The original cable, the main cable, the source of that supply will be overloaded. Before you know it, it results to fire outbreak, electrical fire, because they want to minimize, reduce cost. So you're actually doing more harm than good. So we have another type, the radial. That is what is used in modern day installation, where a cable runs from the distribution board to where the socket is, or where the electric cooker is, where you have your laundry room, instead of doing a ring form of installation. So you may spend more at the initial stage, but on the long run, you are saving costs and you are preventing damage to that installation work. We have the home electrical design layout that has symbols. When you are given a project to supervise, nobody is going to give you the exact picture or exact representation of what you are going to see outside. You are going to be seeing symbols like the ceiling fan. This what is, but this has been upgraded, where they are represented in a more recent with more recent technology. These are the various symbols or representation of what you are expected in your electrical drawing when you are supervising the project or when you're handling the project. This is fluorescent, the 4 feet, the 2 feet. You have the fans, the socket outlet, and so on. They are in your manual. At your leisure, you can go through them and master them. So we have dealt well on this. When you are doing your design consideration, these are the things you need to look out for. The type of supply, which I've told you earlier on, that we have 2 types of supply, the single phase and the 3-phase supply. And the earthing arrangement, we are going to treat earthing in our later part of the session. So you consider the temperature as well when you are doing your design, because the design here in Lagos will not be the same as that in Maiduguri or far north because of the temperature difference. So you have to consider the ambient temperature. So possible presence of moisture is also a factor to consider. Like those of us on the island, we are faced with moisture from the sea, salt content affecting your installation, causing high resistance that will prevent the free flow of electricity of your terminal point. So what you need to do is to put all this into consideration and make plan for adequate maintenance so that we can get quality supply at all times. Fire outbreak is a factor to be considered. Is your generator or your plants sited close to a petrol station or a gas station? We consider that. Extent of mechanical protection required, we consider that. Provision of future modification. Most people just do exact recommendation without making provision for future expansion. There is room for future expansion. So you may see something in Dubai, you want to replicate it here, which is not part of what your original installation is or design is. So you consider any possible expansion. So you create allowance plus or minus 5%. So you consider the operating cost. The operating cost is a factor to be considered. So how much do I need to maintain my appliances or my design? So you cannot see a light or electrical fitting somewhere, you want to come and replicate it in. Maybe over there, they have everything in place. Here in Nigeria, there are some design you will see, for you to change a bulb, you are considering spending 150 or 200,000 naira in present day Nigeria. Why? Because you do not consider the maintenance cost. Just because you want to change a bulb, you go and rent a crane or a scaffold to change a bulb. A scaffold cannot be less than 50,000 or 30,000. And how much is that bulb? Maybe 700 or 1,000. So you didn't consider maintenance cost when you were doing your design. So it's better, it's very, very expedient for you to put all these things into consideration. The revenue cost alternative methods. So if this thing failed today, do I have alternative for it? So you have to put all this into consideration when doing your design. So electrical maintenance cannot be overemphasized. The first consideration is the ability of a cable to carry its required load. As I told you, when you are sizing your cable, when you are after carrying out your load analysis, you're able to determine the size of cable that is required to power this your equipment. If you use underrated cable, you are going to spend ×3 fixing that problem. It's better you get it right. If you don't know how to do it, get experts to help you out so that you will spend twice. So next, all conductor, that is live cable, should be insulated against direct contact and protected against indirect contact by means of fuse and circuit breaker. Like I told you, when you come in contact with electricity unknowingly, the breaker will automatically open. We have what we call earth leakage circuit. It will trigger the breaker to trip. So you'll be safe. You have to ensure all conductors are well protected. All potential electrical conductor, e.g. metal pipes fittings, must be erected. What does it mean? It means that those in time past, we have a bedroom run with copper pipes, galvanized pipes. So maybe during course of leakage current, those pipes might have contact without leakage current. Unknowingly you touch it, you become electrocuted. So it was advised that such pipes should be erected. Don't assume they are free from, so they should be erected. It's part of your building and it's part of your installation. But thank God we are no more using those pipes to run our fittings in bedroom. We are now using PVC. All conductors must provide the excess current protection, that is fuse, circuit breaker. You can see the essence of protection cannot be overemphasized. So you have to ensure that you put adequate protection in place to save you as a person and to keep your installation intact. So testing, why do we need testing in our installation? We need testing so that we can be sure that the installation is fit for anybody to use. So if you carry out tests and ensure that you document it, it gives you a close relationship to your installation. You know when a problem occurs and when to carry out the next maintenance schedule. So testing of your installation, like your earthing system, your continuity test, open circuit test, they are very, very important in installation. I know most of us are doing this. If you have not been doing it, get a book and ensure your technicians do that at every point. Draw a PPM schedule for them. Let them follow what you have drawn, set out for this testing. We have various testing in to carry out in facilities, in your facility. Like the earthing test, you do it twice a year, depends on the topography of your environment. So why do we do the create asset register of all portable appliances? Have a qualified electrician carry out PA test on each item and record the result and any corrective action taken. So it can be a referral. Oh, so thing happened. We may not be there. You are creating process. If we are putting processes in place, you may not be there tomorrow. Whoever step into your office will to go through your records. Oh, such thing has happened before. If similar thing happen, it gives them room to adequately trace out the fault and correct it, because they already have record. They have knowledge of what you have done, and it's good to keep all your records. Don't just do it for the sake of meeting that target. Do it for sake of reference. So we have common electrical problem. They may look common, but they can take you out of your job. They can sack you. Maybe it can sack you. It makes you look stupid if you don't pay attention to them. They call it common electrical problem. This is the problem we have everywhere. One of such is flickering light. You see light at the passage, at the entrance of your building, which is supposed to be the eye of the building, beauty of your facility. So one is coming, your bulb is flickering, is blinking. You didn't take note, you think it's normal. Your boss or your MD will take note of it. Maybe we look at it for 2 or 3 days and it's still there. So we draw your attention to it. Do you know why you are here? So they are common. So your bulb is burning out every now and then. You just confuse. Tomorrow they call you again, the bulb is out again. Next morning, the bulb is out again. So that means you are not detailed in your work. What you need to do? Why is this bulb burning out every time? You check. It might be that the lamp holder is faulty, or the switch itself is faulty. So you take them one after the other. That's what we call troubleshooting. You troubleshoot. Oh, I changed this bulb today. Yesterday, today is gone. Okay, let me change it now. You change with lamp holder. The same thing happened. Okay, let me go beyond lamp holder now and go to the switch. You change the switch. The same thing. Okay, let me even check the connection, the cable that is connecting it, the wire that is connecting it. You see that there's a short circuit somewhere. It's touching, partial contact. It's not firm. So that means you are detailed with your work. Another problem is phase reversal. Maybe public supply officials like EKDC came to address a fault. On terminating back, they mix up the phases, and your elevator is on. Instead of going clockwise, it's going anti-clockwise. That means the lines are non-well positioned. So what you need to do, you call them and relay the issue to them, and they will come and fix it. Another one is phase loss. This is as a result of open circuit. Maybe there is a broken cable somewhere, so the phase are not complete. Your phase failure does not allow the remaining two to come in, because it will damage your equipment. So trippage circuit breaker. A number of reasons are responsible for trippage circuit breaker. So as I told you, you have to ensure that the problem that caused the trip is resolved before going to switch on the circuit, so that you may not be electrocuted or damage more equipment. Ensure that you identify the problem and solve it before switching on the circuit. They look common, but you have to pay adequate attention to them. So these are the problems. This is how you solve them. So fault, causes of fault, solution / remedies. So when you notice this is what you do, then your manual. So consumption monitor. Why do you need to monitor your consumption? In summary, why you need to monitor your consumption? It helps you drive down cost. It helps you to drive down cost. Maybe you assume a facility and the consumption is about 2 million at the end of the month. They are paid, they will tell you it's normal. This is what we have been paying. We have been paying 2 million. It's normal. What you need to do is to look inward. Why are we paying this 2 million? Is it justified? So you move around as a facility person or as an electrical person, you move around. There are things that are not meant to be on. Maybe some people left the office and refuse to switch off their lights, or they leave some fans on. Even AC, air condition, they are working. Nobody is in the office. So in the first month of your resumption, you go around and note them down. On your own, switch them off. You will see that the consumption will drop the following month. So wastefulness allows your bill to go up. The reason why you are employed as an electrical personnel or facility person is to reduce cost, is to bring down cost and minimize risk. I know risk cannot be eliminated, but we can reduce it to the barest minimum. That's the number one reason of being a facility person. So we have parametric system. There are different types, maximum demand, and a check meter. So check meter is used for multi-tenanted facility where various people, we have floors occupied by various customers. What you use there is check meter. You take the reading month to month and pay them accordingly based on their consumption. The way you do this is total cost of producing such power divided by the total consumption for the building multiplied by individual consumption. So everyone gets their own. There is no argument. Oh, you overpay me or you don't overpay me. We have the maximum demand. That is what we use for commercial buildings. So it's a skippered meter that reads every consumption in a building. So it helps you to save headache. It's so convincing that nobody will want to argue it. Extra low voltage system. Why do we need them in a building? There are some facility or some equipment that cannot operate on alternating current, that's high voltage. Like I told you, we have alternating current and direct current. So this is the reason why we need direct current in our facility. We cannot rule it out. Most people make use of UPS. UPS produce uninterrupted power supply as a UPS, uninterrupted power supply. So direct current, a constant current flows through it, or a constant power flows out of it and power this low voltage. Example of low voltage system are the card access control, closed circuit television, your CCTV. They cannot run on high voltage. Security burglar alarm, fire alarm system, and PBS. You can see why it's important to know the voltage that you have in your building. Some people still make use of raw power on their computer, and they are fixing their computer every now and then. So computers are meant to be on UPS. Anything that does not accommodate distortion or disturbance, you put it on UPS. Your photocopier should be on UPS. Your computer system should be on UPS. So we have transformer. As I said earlier on, transformer is not a generator, but it's just a switch. It's switch from high voltage to low voltage, or from low voltage to high. We say modifier. That's the word transformer, transforming. It can transform to a high, it can transform to low. So we have various sizes, and they are used for different purposes. We have the power transformer, we have the generating transformer, and so on. So these are the various transformers for different reasons, for different purposes. So this one is used as in a high-rise building where there is limited air in a confined place. So they are maintenance free. What you need to do is just to ensure that the terminals are not contaminated by dust. So they are open. They don't need oil, they don't need water, they don't need anything. All they need is natural air. So they are used for high-rise building on the island. This is liquid transformer. I have not seen this before. So it's part of transformer that we have in place. So we have different type of maintenance on transformer. You have weekly maintenance. These are what you look out for when you are carrying out weekly maintenance on transformer. We have monthly. So these are the things you look out for. You check the oil level, the oil cap under the silica gel, the breather hose, and so on. These are what you do on a monthly basis. We have the biannual maintenance. We check the flash point, the sludge content, dielectric strength, resistivity, water content, acidity, etc. That's what we do biannually. We have what we call annual maintenance. We do check transformer bullshit for crack. If there's any crack, there will be partial contact. It will not allow the desired amount of energy to pass through it. So you check transformer cooling system, the vents, check if they are if they are breathing very well. You check. You clean the bushes with soft cotton cloths. You check the OLTS coil. You check the Michelin buses and so on for your annual maintenance. So why do we bring you into this? They will tell you we want to do your transformer maintenance today. Most of you, we don't pay attention to it. So before they start their work, these are the things you need to check out for. Tell them to give you their work scope, the scope of what they are coming to do. You compare with what you have learned today. Are you carrying out this? Why are you not carrying out? You are meant to do this. You let them know that you know what they are doing. Some lawyers do all these things. What they do is just to clean it, the surface is shining, you feel they have done maintenance. Whereas they are only prolonging the evil day. So 2 years maintenance, you check the winding turns indicator and oil turns indicator, oil temperature indicator and winding temperature indicator. Those are the things you check. You do the calibration and so on. You measure transformer bushes. Again, you can see the importance of bushes. Perform dissolved gas analysis of transformer oil. So it will give you, just like in chemistry, you want to test the strength of oil. These are what you to know whether the oil is still capable of sustaining that transformer. So you do this once in 2 years for transformer below, and so on. So yeah, we have what called special maintenance and special tests and pre-commissioning tests. So before you start using it, you do pre-commissioning tests on your transformer. So we have generator and fuel management. So you have to know what a generator is. A generator produces electricity and give it out for external load, while a motor receive from generator and to drive itself. Motor does not produce, but the generator produces. Motor receive is give and take. This is generator, this is motor. This is how the sound. This is generator, this is motor. So a machine that converts mechanical energy to electrical energy for use in an external circuit. So they don't produce for themselves, they produce for others. So provide almost all the power for electric power grid. So like we have various types, we have the alternator, the wind turbines. The alternator is the main thing there. Even the generator you use at home, they have alternator here. That thing that rolls as is rolling is producing electricity. The same thing with the Kainji. If you ever been to generating station like Kainji and Shiroro, you will see a massive alternator being driven, a shaft driven by waterfall. As water is falling on it, naturally set it on motion, electricity is produced. The same thing with wind turbine you've seen around, those that look like helicopter. As long as breeze is driving the turbine, the shaft, so it's set on motion. As long as that thing rotates, is keep producing electricity. That is a generator also. Anything that produces electricity is called a generator. So electrical motor convert electrical energy to mechanical energy. So the energy is received from the generator used to drive itself. That's why AC, we have fan motor for your chiller. They require electricity to work. Well, they cannot work on its own. So that's why you need to pay attention to your generator set or source of power to your building. We have type of generator. We have the single phase and the polyphase. Single phase is the one that you have at home like this. While this polyphase is all the like the Meccano, the Caterpillar, the Cummins, ranging from 10 kV to over 2,000, 3,000 kVA. So, as I said earlier on, installation of generator, there are things you need to put in. You don't just say, oh, this building is big, let me go for 10,000 kVA. No, it doesn't work like that. What you need to pay attention to is the load that you have in that building. How many loads? What are the capacity of this load? One of such things to selecting a generator is determine the sum total wattage, the total power that is in that building. It could be 1,000 watts. And if you have 1,000 watts in a facility, do you go for such exact 1,000? No, you can go for 1.3 or 1.15 because you are going to give some allowance so that your generator will not be overstressed. So determine surge rating. At what wattage or at what percentage will the generator withstand surge? Because surge will be coming from your installation, from your equipment. So you determine generator that will be able to withstand such surge for some time without tripping.
Yeah, still success.
Hello? Okay, please minimize the interference. Ensure voltage rating match. As I told you, we have three-phase, single-phase voltage. We have 415 and 400. So depending on the type of equipment that you want to run, ensure that the voltage rating matches the generator you are buying. If you go and buy a generator that is rated 60 hertz, that's frequency, or 260 volt minimum, so you cannot work with the equipment because our equipment operate between 220 and 240. Anything outside that or below this is out of range. It will damage your equipment. It will blow off your equipment. So you have to know, pay attention to all these things. If you want to see them, you check the nameplate of your equipment. They are written there. So you check the voltage that is rated, the power that is rated as well. From there, you select the right generator. Power factor also, 0.8. That's the value of power factor. You check if it's 0.8. If it's not 0.8, you ask why. Can it work? If they say it can work, tell me why I need to go for it. We have procedure for installation. If you don't know how to do your installation yourself, I know most of you are above this, you get a qualified technician or authorized dealer to do that for you. You comply with the standard operating procedure, that's SOP. Confirm if the generator meets the latest standards. After all this, you have to perform these following actions. Inspect generator to detect any damage. You have to carry out all these physical check to see whether there's any damage to your generator and being able to operate the generator after installation. As little as batteries or fan belt on a generator, it can cost you your job. Ensure that your battery is charged all the time, and the fan belt is not weakened or do not cut. Ensure that you check them and pay attention to all these small things, these things that people underlook and eventually cost them their job and make them look stupid before every other person. So these are the safety precautions when carrying out installation. One, proper installation of the exhaust system. Ensure that the exhaust is well positioned so that there will be a feedback from the exhaust. The smoke that's supposed to be expelled out is coming back, circulating within the generator and causing your radiator to choke every now and then. So it costs you more to flush your radiator and also damage the shorten the lifespan of such machine. So ensure that the exhaust is well positioned so that when the fumes are expelled out, the atmospheric air should be able to dissolve it. Provide adequate ventilation. Don't put your generator close to the wall where you have the radiator. So heat will not be able to go out. The heat will just be recycling, coming back within the generator cabin. So what you need to do, ensure that the radiator is well positioned away from a barrier that prevents the heat to be going out. So these are other precautions that you need to take. So we have alternator. As I told you, generator is mainly composed of alternator and engine block. So alternator has two components. We have the rotor and the stator. These are the two that move in opposite direction to generate electricity. They operate under the law of electromagnetic induction, as Faraday's law of electromagnetic induction and Lenz's law of electromagnetic induction. We have components of alternator. We have the stator and the rotor. This is where contains a set of electrical conductors, one in a coil that is over an iron core. The rotor is the one that rotates. This one is stationary, doesn't move. This is the stator. This is the rotor. This one moves inside this, and okay, we are going on 5-minute break. I know some of you are exhausted. I give you, we are 6:19. By 6:25, we'll continue the class. You can go for your 5-minute break. Thank you. If you have you are welcome from the break. I hope everyone is seated.
Thank you very much, sir. Yeah, we are all seated.
All right, thank you. Yeah, as I was saying, we are in fuel system now. So another important part of the generator you need to pay attention to system, because fuel is like the blood that flows through. Fuel is like the blood that flows through human being. So if there is any stoppage along the line, the generator will cut off. Just like the generator will break down. What does that mean? It means that you need to pay adequate attention to the fuel that your generator is used, and also ensure that those elements that allow the flow of fuel from one point to another are well cleaned. Just like say, ensure that your heart or your vessel is clean. So what from the fuel that they bring to your site, you start from there. That's why you need to carry out tests before taking your diesel. If it's not okay, don't compromise standard. They might want to influence you or bribe you their way through. But when they go, the generator remains with you. If you take adulterated fuel into your system, at the end of the day, it will damage your generator and cost more for your company. So you spend more by that little bribe that you take from them. And I believe some of us, many of the people here that I'm talking to are not such people. So what am I saying? The fuel that comes to your site have to be tested. We have a range that we look out for between 0.83 to 0.86. Anything outside this, don't accept that diesel. Apart from gravity test, we also look at water content. Is it free from water? If it's free from water, you accept it. You accept it. You also check the color. You check the color. There are kits, testing kits that are used for this kind of testing. So we'll get there in our next slide. Also, the injector, ensure that they are operating well, they are clean. When they need to be serviced, ensure you service them. Don't feel you are saving costs for the company. You don't carry out the maintenance you are supposed to carry out. The cost you feel you are saving, when problems start coming up, you will spend times 4, times 3 of such amount that you have used for maintenance. So fuel for an integral part of a generator. Without the fuel, the generator cannot work. So these are the things you need to do when they are meant to. So we also have the cooling system. What do they do? As I told you, don't block out the cooling system. Let there be free flow of air. Like fresh air comes in, hot one goes away. There'll be cross ventilation. And exhaust must not be blocked with fume or with a carbon. Ensure the exhausts are heated up. You heat it to remove those carbon. Battery charger, ensure they are charging at every point in time. As the generator is working, the battery is charging. If your panel is such that it takes current for the battery, install a battery charger to continue charging that battery. Because a battery can cost you your job. Maybe a board meeting want to start, you assume that the battery is okay. Maybe your charging system is not okay. You want to start your generator, the generator refuses to start. You are battling with a just common battery. Your employer will be looking at you as if you don't know what you are doing. Don't overlook, don't commonize this simple thing. This is what the white men will come to do in Nigeria, and they will pay attention to it, they make money from it. But we look at them as what is on generator. Battery can cost you your job. Radiator choking can cost you your job. Overheating. They are in a board meeting. The generator is working, suddenly the gen shuts down. Why? Overheating. So you need to pay attention to all of this. So the control panel ensure that all the wire system there are intact. All the connection, the terminations are intact. You have technicians. First, encourage them to do this. Some may go with piece of paper and mark them, okay. Once in a while, you go there by yourself and check if what they are telling you is correct. Verify. There is room for trust, but you also need to verify what they have reported to you. You need to check yourself and ensure that they don't put you in trouble. So we have daily maintenance of generator. These are the things you check: oil level, coolant level, air cleaner indicator, and so on. Ensure this is the checklist here. Let them go run on a daily basis and mark it. Give them another one tomorrow. It shows that you are monitoring your equipment. You know what they are doing. So you put it in your record. These are the things that you use to generate your monthly report. so you don't overlook them. So every 200 or every 250 hours, you maintain your generator, you service your generator. These are the things you do for this number of hours. Change the fuel filter, replace engine oil, and so on. So I know many of us know this, but you have to ensure that when they come to do your maintenance, these are the things this form part of the scope. This is the scope they should show you. Oh, after maintaining, you check. Yes, they will actually change. If you don't change them, the generator might still work for you, but with time, start giving you problem. Start giving you problem. Before you know it, your company is spending more. You'll be complaining. Oh, they are not of staff. They are not increasing salary. They are not doing it. They are not doing that. Whereas the money you are supposed to save for them, by which the purpose they employ you, you are not paying attention. And then when you do all this, you save money. You're able to justify to them. When I came, this is how much we're spending on maintenance and repair. When this time, this is what you are spending. I'm able to reduce this cost, to make it a point of debate. Justify it with facts and figure. You were paid 20 million. Now you are paying 15 million or 18 million. You show the trend, what you have done, the measures you have put in place. Nobody will want to hear that and not give you recognition. So this is the reason for this class, to do things differently the way you have been doing it. So you have to pay adequate attention. 500 hours, this is what we do. We inspect radiator cap. That radiator cap can put you also in trouble, can be giving false alarm when it's vaporized. So it can be giving you false alarm, shut it down. The sensor will be sensing and shutting down the generator. You go there, you check, you uncheck it, the generator goes back. So you check all the little things. Ensure they check it. You may not be the one doing it yourself, but ensure those people, if possible, show me pictures. The era of WhatsApp now makes work easy for everyone. As you are doing it, snap it and send. Snap it and send. I can hear some interference. Please mute your phone if you are not part of the admin. Take this class seriously, please. If you are operating your phone while in this class, it doesn't make sense. You have paid heavily for this. Even if your organization is sponsoring you, you know the time, what it is to attend this class. Please take it seriously. Interference should be eliminated, please. So these are what you do 2 to 3 years. Diesel management I've dealt on this. I will just put you through properly achieve total control of the diesel. As I said, if they say it's diesel, you have every justification to tell them, no, it's not my diesel. I've done the testing that I needed to do. I've washed my tank. I've done this. I've done that. You have control over it because you do not compromise. It's only when you compromise, whatever they tell you, you agree. So it helps you to monitor diesel stock. If nobody takes you unaware, you know when to order for diesel and when not to order. If they are calling for you to order for this, no, I still have social number of total quantity of diesel on site that will be able to take me for at least worst case scenario a week or 5 days, 5 working days. So you can beat your chest and say my diesel is intact. So you know the consumption pattern. Like when you are full load, you know how much you consume. When you are minimal half load, that's 50% load, you know what, if you are minimum load, as a off-peak period, you know what to consume. So that's the essence of proper diesel management, what you can achieve. Diesel supply, before you take, as I told you, before you allow diesel into your storage tank, ascertain the quantity supply, test diesel at the point of supply. They will tell you, oh guys, this, you can see it's very clean, it's very clean. Take it. No, there are testing kits that enhance your testing. You test them. If you don't have, go and buy now. it makes life easy for you. Go and buy if you don't have. So diesel supply must be proven to be compliant with industry set standard. Fire diesel decrease generator performance. Fire diesel damage the generator. So you should be running. You leave your FM work or what you are supposed to do and be running after diesel because someone has compromised standards somewhere. So it takes you off your job. You'll be running like a technician, running up and down, diesel, diesel, diesel. Whereas you are supposed to do the testing before taking the diesel. These are pH, this is pH test. So as I told you, this is to test the alkali and acidic nature of your diesel. The range is between 6.7 to 7.0. Anything short of this, don't accept the diesel. We have clarity test. Ensure that the diesel is clear enough. It should be free from impurity. We have texture test. We have specific gravity test or density. This is what most of us do. So as I told you, in Nigeria, it's between this range. Anything outside this, don't take it. But this is industry standard. This is what has been proven okay. So anything outside this range, don't take the diesel, no matter how close or how the relationship you have maintained with the vendor, don't take it. So we have, the last module is the earthing, that's the grounding system. Why do you need earthing in your installation? Why do you need to earth every part of your installation? There are so many reasons why you need to do this. So what is earthing? Earthing is a system of circuit that connects part of an electric circuit to the ground. That's the green wire you see that run from your distribution board to the ground into the copper rod that is buried in the ground, like this one you are seeing, like this one here. This is from the installation house into the copper rod buried in the ground. Example is this one that you can see very well. You can see this one is a bit burnt. What goes through the earth cable is a nuisance current, unwanted current, bad currents. So they leave your installation. They are supposed, if you don't have good earthing system, it will start damaging your equipment. So when there is fault current within your installation, it passes through this place to this copper rod and goes to the ground because the earth will receive it. Earth is taken to be 0 ohms. The resistance of the earth is very low. That's why fault current tends to flow to the weaker point. The earth is a weaker point compared to your installation, to your equipment. So that is why earth is very, very, it conducts fault current from your installation or from your home to the ground. Current that is capable of putting your house on fire. Current that is capable of killing a soul in the house or in the facility will be conducted to the earth. If your earthing system is bad, also it increases electricity bill at the end of the month. It costs more on your electricity bill because that fault current will be circulating around your installation. It will form part of your current that you consume, whereas you did not consume it. It's supposed to be a wasted current, fault current, bad one. So if it's big enough, it will cause fire in the building. If there is thunder strike, it will result to fire because you have poor earthing system. There are ranges by which you look out for when you are doing your earthing system. Or if you already have one in your facility, what you need to do is to carry out test. There is a range 0.004 ohms. Let's say, yeah, 0.004. That's the standard. If it's or 0.4 ohms. If it's above this, you know that your installation is at risk. You have to treat that earthing arrangement, service it so that you can achieve the desired value for a good earthing system. So how do you improve earthing system? There are things that are set aside. Electrolyte, because it's about conductivity. We have what we call liquid in conductor in liquid form, like salt in water. It allows a passage of electricity to pass through it. It conducts electricity. That's why your battery, the current you have in your battery are liquid current conductor in liquid form, like the mercury, the acid, so sulfur 4 oxides, chloric acid. They all conduct electricity in aqueous solution. So the same principle you take to your earthing system. If your earthing system is compromised, what you need to do is to lower that resistivity, because there's a resistor that is opposing the flow of current. So what you need to do is to pour salt in water and pour it there, or use charcoal, because charcoal is an absorbance of impurity. Any impurity that is surrounded that, and if you put charcoal around it, that's carbon, charcoal, it will absorb those impurities. It's an absorbing agent. It absorbs those impurities and make sure that earth parts is free from impurity. It will allow free flow of electricity into the earth when there is earth fault, when there is a leakage current. So when you are doing earthing, ensure that you use the right cable size. If you use underrated size, it will not function properly. If you use overrated size, it will not function properly. So your installation, the capacity of your installation determines the type of earthing arrangement that you have in place. There are some buildings that have about 6 or so. There are some that have 1. There are some with 2. So ensure you employ the service of a qualified technician or engineer to help you in your design layout and your earthing arrangement. So what are the usefulness of earthing system? So they protect structure from lightning strike. Direct the lighting through the ground system into the ground air. Prevent lighting from passing through the structure. So if you look very well, you see a kind of a rod. So when there is lighting system, it picks it, send it through that wire, that earth cable to the ground without coming into your building. So if you don't have it in place, ensure you have it both home and office. What you need to do after this class, go around, ask questions. Where is your earthing point? You need to know your earthing point. Maybe they are pouring oil there, waste products. It will affect the conductivity of that place. Ensure you know them, identify them, and mark it earth point. So you do servicing every 6 months. It's recommended for everything. Depends on the area. As you can see here, what goes through this place is heat. Current comes with heat. As this place is heating, it's passing here. This resist, it will be burning, it will be caking. Before you know it, it will form a solid block that resists the flow of electricity. When a fault current is coming, it will send it back, because fault current tend to go to the source. If it does not see where to escape, it will go back to the source and damage any equipment that has low resistance in the building. It will tend to pass out. If it's human being, it will pass through your spinal cord. That's why most electricians suffer spinal cord injury, because spinal cord is considered as the weakest point of the body. So they tend to pass through the spinal cord. So it is very important you pay attention to your eating. It's common, but you have to give it adequate attention. So these are the things you need for your eating system. For the sake of lighting system, this is what you need. This is what you need for your building or installation to be protected. You are talking, please, somewhere. Ekemini. You are talking somehow. Please mute your phone or your device. So this is what you need to do when you are carrying out tests. Perform ground testing regularly is expected. The soil nature. Rainy season, the earth is a bit loose, so there is free flow of particles, molecules, or ions in the earth. For dry season, when the whole place is dried up, the earth is a bit caked. What you need to do is to test the earth resistivities at regular intervals to know whether your system, your installation is at risk or not. So, like here, we have recommended that it should form part of facility maintenance plan. It is very, very important. It should form part of your maintenance plan as part of your PPM. Drive it, you are the one to drive it. As a facility manager, you are the one to drive it. Some people, we don't need it, we don't need it. No, because they are ignorant of what will happen if you don't do it. After this class, don't condescend to their way of doing things. You have come to improve yourself. They should see some improvement in your industry, the change that you are bringing. Ensure you have book for all these activities. Document them. Earth test was done, so earth improvement was done, so the next, just like you plan for what's it called, fire extinguisher. Just like you know that every 250 hours you do your generator maintenance. Are we together? Are we together?
Yes, sir.
Very well, sir.
Okay.
Yes.
So, equipment grounding requirement to limit the voltage to ground on the materials. To prevent electric shock. These are the usefulness of earthing, the advantage of earthing. Prevent electric shock. I've said something about this several times. To prevent electric shock. To prevent the destruction of electrical components. That's why when there is a thunder strike, oh, your home theater or your TV will just go bad, will go blank, because that effect of thunder strike was directed to has been directed to your home, your equipment. As I told you, in electrical engineering, electric current flows to area of weak resistance. Weak resistance, just like water. Water cannot flow from bottom to top. Can it flow from bottom to top? No, to top, no. The same way, water flowed from hill to bottom, from top to bottom. Same way, electricity flow, look for a weaker point. Like water, for example, block water in this way, look for another way to come out and continue its movement. The same way, electricity. So the earth has been seen to be at zero potential. Zero potential. It's at a neutral level. That is why whatever fault current that is coming will go to the earth. The same way, you see bird hanging on the top of electric wire. They are not electrocuted. Most of you don't know the reason why. The reason is this. If there is no work done, just like your table that is flat, it's so flat, it's of a equilibrium. Let me use the word equilibrium. At an equilibrium, if you put water on that table, it will remain there until you bend it to a certain direction. The water will begin to flow to that direction that you have bent that table. As long as that bend remains on that wire, work is not done. Electricity is not flowing. It's at the same potential, Just like a boxing competition. This one is beating me, I'm beating him. I don't know, they call it unanimous decision also. No winner, no loser. The same way, as long as that bell remains there and work is not done, it will not be harmed. Human being can as well remain there and not be electrocuted. The only thing that can make you electrocuted, if you have some other equipment that is different from the wire that you are holding. If you have a copper, maybe the conductivity of copper is higher than that of aluminum. The current will tend to flow from that copper, that of aluminum to the copper. That's when you receive shock. As long as work is not done, there is no flow of electricity. There is no flow of voltage. The same way, electric flow to the ground is at zero potential. So your equipment, your radio has a certain range that it must operate. That's why I told you every equipment has their rated value to operate on: frequency, voltage, current, and so on. But earth is considered to be neutral. That's why when you have a fault current, it will flow to the earth because it's weaker than your installation. Is that taken? So ensure you do your earthing maintenance at regular interval. So these are the things you need to check out for your homes: the type of ground, the nature. A stony ground in the north require regular maintenance of earthing arrangements. So you are going to be giving this assessment. So you write and submit to the administrator. This form part of your coursework. If you have any question, you can ask so that others can benefit from it. Thank you. I can see some hands raised up. Theophilus, right? You can ask your question now. You have another 5 to 10 minutes for your question to be attended to. Go ahead, Theophilus.
Thank you, sir. Thank for the lecture well presented. My question is still on the consumption of in a building, both the residential and the commercial. When you have different people in a building, you are trying to give us the formula to calculate the rating of individual consumption. Please, I still want you to throw more light on that formula. And secondly, checking of the earthing. At what time can we check the earthing maintenance? Is it day, month, or sir?
Okay.
Yes, sir.
Like I said, okay, more question. I will attend to them sequentially. So Kumbi Adiola, are you ready? Okay. Who is raising hand?
Okay, sir. Good evening, sir. Thank you for the class. I really appreciate. Okay, I want to ask, sir. You said those what we have in our facilities, what we have in our buildings, make up power, like loads, all those things. My question is, if you have like appliances that have like watts, how do we calculate watts to the horsepower? Because when you have a generator that is like 2 horsepower, and I have loads of things to put on it. How do I know that, okay, this is the amount of watts that will make like 2 horsepower, so we don't overload the generator or something? Thank you, sir.
Okay. All right. Yeah, I will take Theophilos' first question and take the second question. So can you see my screen?
No, sir.
Okay. Okay. Can you see the example I'm presenting now?
Yeah, yes, sir.
Okay. If you have like how to check tenants meter, right?
Yes, sir.
Let's say you have 4 tenants.
Okay.
With different consumption rates.
Yes, sir.
Let's say 700. Let's say 600. Sorry, let's say 500.
Okay.
You understand? Let's say the cost of generating power, whether diesel or electricity, is, let's say, 10,000.
Yes, sir.
Right?
Yes, sir.
So what you need to do is to add this in. This is in the kilowatt now, kilowatt hour for all the tenants A, 1, 2, 3, 4, and 5. You understand?
Yes, sir.
Okay. 4, let's say 4. This is the total.
Okay.
So what you need to do, this is cost. This is the cost for power cost.
Yes, sir.
I call it PC, power cost. So you divide this, let me take this one here. Sorry. Let me take this one here.
Yes,
power cost. This is total power cost, PC. Total power cost. All right. This is total kilowatt hour. You understand?
Yes, sir.
So you divide this by this. That's the total cost. Divide by total kilowatt hour. No, let's say, sorry. Let's say this one is let's say 25,000. Let's say 25,000. Okay, let's leave it at that. Let's leave it at that. I'm coming. I want everyone to have an understanding of this. So it will be this,
yes, sir.
Total cost divided by total consumption. It will give you this. It will give you this. So this is the ratio you are going to be multiplying with now. Just follow me. So I think, okay, for you to get individual cost for the month,
yes, sir.
Cost per month, will be this times this. It will give you about so. Are you with me?
Yes, sir.
This is the cost for number apartment.
Yeah. We're lost.
No, you can't be lost.
Where did you get this 3.92773?
Not
How'd you get
clear.
that?
It's
This
10,000
is
divided by.
sorry.
How do you get the 3.9? 3.9.
This is
That's the total cost.
kilowatt hour. This is individual kilowatt hour per floor. You add it up to get the total for the building. This is the total for the building now. This 2,546, right?
Okay.
You divide this, the total cost of power, total power cost divided by total kilowatt. That's how I got.
Okay.
Which I brought to this place. It will be your multiplying factor. So to get cost for apartment 1, it will be this multiplying factor that you have gotten times individual cost. It will give you about 2,000 something. Yeah, 2009. So that's what you would do for all of them.
Yes, okay.
So if you add up all this, it will give you about 10,000 or so. Let's do it. You see it? Did you see it?
Yes, sir.
Okay, that is how you get it. On your own, try to, if you can screenshot this, try to understand it the way you understand it. This is cost generated per floor for the 4 apartments. You add it up, it gives you, so this is your maximum demand now. It gives you 2,546. And then your total cost of, maybe cost of diesel and electricity is 10,000. That's how I got this 10,000. I divide this 10,000 by the total kilowatt hour. I got this. So I brought it here to multiply each apartment to get the actual cost per apartment. Apartment 1 consume more. That's why they are paying higher. Apartment 2 consume further a bit higher than 2, 3, and 4. That's why they are like this. Apartment 4 consume lower. That's why it's pay 1,009 something. Did you get it?
Yes, sir.
All right. You talked about which other question this other one asked. I have spent too much time on this.
Yes, I was talking about eating that at what time
okay, it is recommended you do it every 6 months because of weather changes in Nigeria. I don't know
the private and the commercial.
Yeah, anywhere, both commercial and the industrial, both commercial and the household.
Okay.
Because of change in weather, as I told you earlier on, is heat that passes through that place. As heat is passing, the place is caking, is solidifying. At a point, it will not allow the flow of electricity. So what you need to do is to pour insulation, that is a electrolyte, that is conductor in aqueous form, electricity in aqueous form, so that will lower that. So every 6 months, you have to check on a regular basis and see if it fall within the acceptable range.
Okay.
All right. Which other one before I call it a day?
Is it the same time industrial salt?
Yes, it's in electrical engineering we call it electrolyte. Anything that conduct electricity is industrial salt.
Thank you, sir.
Yeah.
Okay, sir. I asked about how we calculate our watts to make horsepower.
Okay, horsepower. Okay, just look at the Excel. We have 2 horsepower now, and the value for horsepower is 746. 746. You understand? 2 horsepower. If you want to get it in kilowatts or in wattage, it will be this 2 horsepower times 746. It will give you 1,490, about 1,500 watts. Do you get?
Yes, sir. Yes, sir.
The same way, vice versa, if you want to convert from kilowatt or wattage to horsepower, you divide this one by 2, you get 746. Or divide this one by this, it will give you 2, which gives you 2 horsepower. The universal value for horsepower, 1 horsepower is 746.
Thank you, sir.
All right. Thank you, everyone. If you have further questions, you can reach me through the admin, and they will direct your questions to me.
We have questions.
Okay, go ahead. Make it snappy.
Okay.
Okay.
My question is, number one, if you have moved, if you have a facility that is already running and then you find out that it hasn't been earthed at all, can you now go ahead and earth? Is it possible?
Yes, it's very possible. Okay. Very possible. That's why, as a facility person, you do your gap analysis. What is in place and what is not in place. So you make your recommendation and start implementing one after the other.
Okay. My second question is, you explained about the ring circuit where they keep looping from one end to another end, as opposed to the radial circuit. So where you take it from the distribution box directly to the source, maybe the socket. So won't you have so many wires or many pipes running in that case?
No, see, that's why conduit makes work easy. Conduit wiring. You take from centralize your distribution board to where it can evenly distributed. You understand? So that's why you need to seek the attention of experts to help you do this. You do it and you bury it. It's safe. It is safer and save cost on the long run.
Save cost, because the way you have to have like maybe a repair or something.
If you,
that means you have to break
in terms of repair, it makes work easy. You know the breaker that has tripped. You know the line that has been compromised. All you need to do is to disconnect it and use fisher tape to remove it and install another one when you know the cause of that problem. It makes work easy.
Okay. Then if you have like a facility, maybe like an estate or something, how do you, I don't know if this calculation you did, if you want to determine the cost of diesel consumption per each unit, does this calculation apply? This one, the first one you did.
Yeah, it does. It applies. Okay, let's say cost of diesel here is 4,000, and let's say 6,000 or 8,000, and cost of EKDC is 2,000. You understand? So we can determine it, how much cost you spend here. This one would be equals this times this factor. You understand? Okay. Times this factor. No, it's division. We divide it. We divide this. Just for your understanding, because this divide by time is gone, divide by the total consumption. Where's our total consumption here? You have it. This one will be your multiplying factor now. You understand? You break this one here. It will be this one will form this one here and do the same thing. The same thing with diesel, with electricity. Equal to this divide by, let's say, total consumption. We give you this. If you plus these two together, it was this plus this. It will give you the same thing. You get?
Okay, so that will be the cost of both diesel and electricity.
Yeah. Let me do one for you before we call it a day. Because this is this give you the cost of diesel for this. You understand?
Okay.
So that's how you do it. Okay. Thank you. All right.
Sir. Thank you so much, sir.
Thank you for your attention and your contribution. And I believe you are going to see improvement as you go back to your various place of work. And your purpose of coming to this class will not be in vain. You shall reap the fruit of it in Jesus' name.
Okay. Hello, sir. Can you still take one more question?
Okay, for the sake of you, what is be brief.
Okay, thank you, sir. My question is on the earthing system. We didn't talk about thunder arrestor in it, and my question on thunder arrestor is, how do I know the range a thunder arrestor can cover? Because we see thunder arrestors being planted in buildings and all that. What is the maximum range it can cover? I know it can't go beyond. I think so. What range can it cover? At what meter and can the thunder arrestor cover, so that you know if your building is really covered, if you have a thunder lightning and all that? The second question is on the island. What is the resistance? What is the best resistance test resistance quality I should be expecting on the island when carrying out a test?
Okay, like the thunder arrestor for says, like a magnetic wave, like you see this mask as a ray they can cover. That's also determine the size that you need to go for. I don't know the capacity of your building. I don't know what is installed there, what you tend to protect. So what you need to do is to seek an expert advice to carry out analysis of your building, what you have in place, what you need to protect. You understand? So I cannot give you a certain range that it can cover. It depends on the building, like the UBA, for example. We don't expect to have one thunder arrestor there compared to, let's say, another lower building like the Zenith Brown that is close to it. So it depends on the capacity of your building and the equipment, the type of equipment that you want to protect. So the best answer to that is to seek an expert advice to carry out analysis, a kind of assessment to be able to recommend this is what you need to go for. For the earth value, so far I've not seen beyond 0.0000 something, but there is an acceptable value. It's about 4 ohms or so, 4 to 5 ohms. Anything outside this is risky and deadly.
Okay, sir. Thank you very much.
All right. Thank you, everyone. Have a good night rest.
Thank you, sir. Bye.